negative 1. If I double its height, 2 and negative 2. You know that by doubling vertically. I can draw this thing twice as tall, but I prefer to just write it as 2. I'm changing the scale of this instead, just right on the screen. You can draw it, but instead I'm just changing the scale. It's like changing the window on your graphing calculator. I don't actually have to redraw it. I just say, oh, well, if I double the height, it's instead of going 1 and negative 1, it's going to go 2 and negative 2. See? Look. That's my scale. What about shift right pi over 2? If I take this where it's currently at 0, if I go right pi over 2, it's going to be at pi over 2. The whole thing shifts. Well, I'm not going to redraw it over there. What I'm going to say is, well, instead of being starting at 0, this thing is going to start at pi over 2. That's a good one. 0 is easy. Oh, but this one, the pi one, I'm going to have to add pi over 2. So that one, I can do it. I'll figure that out in a minute. 2 pi, I'll have to add pi over 2 to that as well. I'm going to show you how I get those just so you can see the mathematics behind that. Okay, so I'm going to go big. Okay, I'm going to go down here on the bottom. I'm going to show you guys, did you know that pi plus pi over 2 is made much easier if you multiply pi by 2 over 2? See that little dude? If you 2 over 2 is equal to 1, so I'm making a common denominator, and so when I add those now, I get 2 pi plus 1 pi is 3 pi. Denominator stays the same. So this denominator, or this, what used to be pi, if I add pi over 2 to it, is now 3 pi over 2. So I have shifted this to the right, but instead of actually picking my graph up and moving it, I'm actually just changing where the values are, just rewriting them. So one of my fave motions. 2 pi plus pi over 2, I need to figure out what that is. So let's do the math down here. I need to make a common denominator, so I double the top and bottom, so it becomes 4 pi over 2. Got my common denominator. Add those together. 4 pi plus pi is 5 pi over 2. And that, ladies and gentlemen, is my new endpoint over there. You can physically move this thing around all you want. You can actually double the height and make it taller. So you don't need to write this, but I could have gone like this and made it twice as tall. Okay, but I'm not going to. I could have actually shifted it to the right, pi over 2, and put it over here. That's fine, but I chose not to. Instead, what I did is change the scale values. And conceptually, I think there's something important about that. So part of the reason we do that. Okay, onward. We got to keep cruising. Step function. You know the step function. Down 2. The integer function. I'm just going to take it down 2. Let's not get complicated on that one. Oh, that's too wide. Back it up. Try that again. There. There you go. It's just down 2. You start it, instead of at 0, 0, you just moved it down here and start it at 0, negative 2. I'm going to move on from there unless you bring me back. All right, I'm going to try and turn the page. Come on, there you go. Let's go piecewise. Piecewise, these are grand. I love going piecewise. I haven't talked enough about these, so I'm happy to bring this back, and I knew we'd get to this gateway eventually. The one way that I think that can be helpful for doing piecewise is we're graphing all 3 functions, but we're only graphing them for little chunks of the domain. So these are the little domains. So we're going to do the line x plus 5 when x is less than negative 2, the x squared parabola in the middle, and the line y equals negative 2 on the right. One thing you can do, and since I have technology in my hands that can help me with this, you guys can just use the eraser of your pencil, is you can actually graph all 3 and then just erase stuff where it doesn't apply. Like x plus 5. I'm going to graph that first. So I go x plus 5. I'm going to do it in pink. Match my little color coding. Go y-intercept of 1, 2, 3, 4, 5. And I can go up 1 over 1. Draw my line. Cool, huh? There it is. There it is, x plus 5. Then I can go with the other one. Let's go greeny green. Let's do x squared. I love graphing x squared. If you don't know how to graph x squared properly, it starts at 0, 0. Then you go over 1, up 1, because 1 squared is 1. Negative 1 squared is 1. 2 squared is 4. Negative 2 squared is 4. And then you draw your parabola. Cool. That's all 3. Now, I'm going to erase stuff, by the way. This is all of each function. I'm going to get rid of some. And finally, let's go this light blue. Clashes a little with that green. Ouch. Sorry about that. And then y equals negative 2 is that function. Line down at the bottom. Okay, all 3 functions. The domain piece says, you're only going to do it for parts of this. Like x plus 5, we only graph for when we've got x less than or equal to negative 2. So you go to negative 2 up. I'm only going to do from negative 2. I'm putting a dot there, a very solid dot. From negative 2 to the left. And the reason it's solid, actually, is because of that greater, less than or equal to sign. So it starts at negative 2, and we're only going to do this left part. So I'm going to erase the rest. So watch. Getting in there, erasing very carefully. Okay, there it goes. There, gone. See? Pretty, huh? Then I need to get in there and deal with my parabola, which only works for, what, negative 2 to 1. All right. So negative 2 to 1, I can take, and it says less than but not equal to. So what you do is you go to negative 2 on the parabola. It's right here. It's going to be a nice big open circle there because of the less than symbol. It says negative 2 to 1, so I'm only using the inner parts right here, the insides, this part. Whoops. To 1. Oh, we got to find 1. 1's right here. Ooh. So everything else outside of those little circles, those open circles at negative 2 and 1, got to go. So go with my little eraser. I'm going to go back and do this again the way I usually do it in a little bit hyper speed mode. Or normal speed, I should say. So I got rid of all that with nice little circles at the end. Open circles. And then lastly, we got the line negative 2 at greater than or equal to negative 1. That means a very solid circle right there. Got it. To the right. Everything else gots to go. And that's our piecewise function. I got the parabola in the middle, negative 2 to 1, with circle, open circles. Line left of negative 2, including negative 2. Horizontal line at negative 2, starting at value of x equals 1. Okay, great. What if I was being real crazy and I said clear page? Oh dear, hope this is the right button. Okay, got it. Hope I didn't clear the other page. I want that one. But now I'm going to graph these again, but do it a little bit faster. What I usually do for these is I start with the middle function. I usually go x squared, and I say, oh, from negative 2 to 1, open circles because they're not equal to. So I go, all right, parabola. Let's go to negative 2. I know when negative 2 goes in x squared, it's 4. There you go. Go to 1. I know 1 squared is 1. Circle. And then make my parabola in between. Just like that. That's usually where I start in the middle. Second, then I go to the top one there, x plus 5. So I go to that y-intercept of 5, 1, 2, 3, 4, 5, and I go down 1 over 1, down 1 over 1 until I hit 2, negative 2, and I start making dots at that point. And then I connect the dots. We're gone. All right? Then I go to the right-hand function, negative 2, that horizontal line, and it says do it when x is greater than or equal to 1. So I go to 1, -2, very close, dot because of the equal. Done. So you don't have to draw them all in erase. It's just sometimes I think helps to see that it's the whole function. You're just eliminating pieces of it. Onward. Lunch-wise, I have, yes, good deal. See y'all soon.